Hello boys and girls and everybody else. So welcome again to another science video lesson topic. And in this session, we will going to talk about two devices that utilizes electromagnetic induction. So in the previous video lesson, we talked about electromagnetic induction. What is electromagnetic induction? How does it work? And how does it helps us to produce electricity? Now for today, we will going to integrate that particular process in these two devices that utilizes electromagnetic induction. So for today, come join me as we discover what are these two devices in our video lesson this session. Alright, so this is the last video lesson for the electricity and magnetism topic. So for today, we will going to have the two devices. What are these two devices? Which is very important in our modern world right now. Without these two devices, I cannot imagine what is our modern world will look like. All right. So let's jump into it. And on this on this lesson, we are still in the module 1B, which is the electric generator and transformer. And we are done with the electromagnetic induction in the previous video lesson. And I hope you did learn something, or you did get the idea of electromagnetic induction by Michael Faraday. So for today, we will going to have the electric generator and transformer. So basically, you will discover how it works. Right? So how it works and how these two devices helps us in our daily activities. All right. So electric generator. So before that, before we discuss everything about these two devices, the question that we were going to ask is, how do electricity and magnetism work together in generator and transformers? So as we all know, from the discussion of electric motors, we all know that electricity and magnetism have relationship to each other. Has a relationship to each other because of the discovery of Hans Christian Ørsted. All right, and in this topic that we have, we will try to answer. Okay, we will try to answer how does magnetism and electricity work together in these two devices that we have right here, the generator and transformer, respectively. So the objective of this particular video lesson that we have here on this session is that to apply an understanding of electricity and magnetism to describe how generator and transformers function. So basically, at the end of the day, you should be able to describe how these two devices function respectively and how they produce electricity that helps us in our daily lives. All right, so let's start first with the generator. All right, so the generator. What is a generator? A generator is a device that uses induction to convert mechanical energy to electrical energy. So, is this statement sound familiar to you? Okay, yes it does. It's because this is the same definition, all right, but in reverse. This is the same definition as your electric motor. Whereas the electric motor is a device that transforms electrical energy to mechanical energy. A generator transforms mechanical energy to electrical energy. So a generator is a device, all right? It is a device similar to an electric motor but in reverse. So it uses the idea of electromagnetic induction. So generator is very important in our modern society today or modern world today because it generates electricity. Right? So the electricity that we use every day in our homes and in our task, all right, every day is coming from a generator. All right, it comes from a generator that converts this mechanical energy from other raw materials to become an electrical energy. All right, so the generator, as we discussed, it is working using an electromagnetic induction process. So in the electromagnetic induction process, as long as there is a changing magnetic field, all right, so in this case, we have your rotor. So there's a changing magnetic field that we have right here. It creates or it induces electric current in your coil of wire. All right, so voltage, then electric current. So as long as this rotor continues to spin, the current will be it is continuously produced in the process. As the rotor stops, the current production also stops. All right, so let's watch my demonstration. All right, let's watch my demonstration of the transformation of motor to generator. All right, so that you will now we will have an idea that the generator and the motor are not too different from each other. All right, so let's take a look at it. All right, so I have right here a device called the generator. All right, so I have here a device called the generator, and in this generator, okay, so as you can see on this generator, right, so the magnet or the coil is spinning over this magnetic field that you have right there, and the wires that are connected to this LED that you have. Okay, so it lights up as long as I turn this wheel constantly or continuously. Right, so as long that there is a mechanical energy coming from this rotating wheel that rotates the coil inside this mechanism over here, right, it continues to give off it continues to produce electricity in the process that lights up this LED bulb that we have on this demonstration. All right, so can we transform this generator to become a motor? So yes, it does. So we can have it like this. Okay, so this is the transformation of that same device to become a motor. All right, so okay, so this time the mechanical energy, so the turning of the wheel, right? This mechanical energy is possible because there is an electrical energy. Okay, there's an electrical energy that supplies this one connected to this power source that we have right there. All right, so another video that I have right here, this one. Okay, so as you can see, this is now a motor. So a while ago, it is a generator. Now this is now a motor. This mechanical energy is possible. Right? This mechanical energy that you see here, this mechanical work that you have right here is possible because of this electrical energy that you supply that electric motor. Right? As long as this thing is connected to the power supply, it will continue to move. Okay, so that is the electric motor, mechanical to or electrical to mechanical, and the generator is mechanical to electrical energy transformation. Alright, so that's the key idea there. Okay, so that is the basic idea of generator. So we have two types of generators. So we have the DC generator, which this is a type of generator that produces direct current. Alright, so the direct current. Now, it also contains the permanent magnet. Same as your motor, it contains a permanent magnet, a loop of wire, and a power source over here. Alright, so this permanent magnetic field produces this magnetic field that is perpendicular. It is perpendicular to your loop that is located at the center. Right, so in the DC motor, or rather generator, the same as motor, it has commutator. Instead, it has commutator on its one of its main parts. So that is one of the main characteristics that you should take a look on your DC generator. So it produces a direct current. Now, how to know if you want to know the direction of current, the direction of the force, and the direction of the magnetic field in a DC generator or a generator, any kind of generator, you can use the left-hand rule. Alright? So you can use the left-hand rule. So for the... Alright. Now, the right-hand rule, this one, the second right-hand rule is for electric motor. Alright? This is used for electric motor. So remember that in the right-hand rule, we have the thumb as force. Alright? And we have this finger, this index finger as the current. and we have your middle finger as the direction of the magnetic field. Alright, so that is the right hand rule for electric motors. But for the generators, we use the left hand rule. But it has the same representations. So force, current, direction of current, and direction of magnetic field. But it is in the left hand. So we call this one as the Fleming's left hand rule for generator. So again, this is for generator. Left hand is for generator and right hand is for electric motor respectively. Alright, so that is, if you want to know the direction of current, if you want to know the direction of force, and if you want to know the direction of the magnetic field in your generator, you use the Fleming's left hand rule. Alright? Okay, so that is the basic idea about this generator. So, the current that is produced by DC generators, so none other than the DC or direct current. So, the direct current that you see on this graph that you have right here is just in one direction. So as you can see, it has only one direction. If this is positive, the current only runs in positive direction. So technically speaking, that the DC is a unidirectional current. Alright, so that is a unidirectional current. So that is your direct current. Unidirectional. Alright, so that is the direct current. And some examples of the direct current motor that we have right here. So in some different purposes, okay, in which these motors or these generators are being used. All right. So the next type is the AC generators. All right. So the AC generators are generators that are found in some in power plants. All right. These generators helps us or produce electricity that is needed, all right, that is needed by everyone, all right, in their daily task. Okay, so again, it has a permanent magnet on both sides, but the difference between AC generator and the DC generator is that it has slip rings. It doesn't have commutator. It has a slip ring, so it doesn't need a commutator for this one. So in this case, it follows the same principle as the left hand rule. So if you want to know the direction of current, the direction of the magnetic field, and the direction of force that is acting on this AC generator, you use the Fleming's left hand rule. All right, so that is the AC generator. So you have now an idea on what type of current the AC generator produce, none other than the alternating current or AC. All right, so in the alternating current is two direction. All right, so two direction current is very important because of transmission. All right, so the transmission of electricity, all right, makes this two direction current or the alternating current advantageous. All right, so periodically the current changes direction over time. So sometimes it goes to the positive direction, and after some time it goes now to the negative direction. So two direction, so it goes in the opposite way, right, periodically. All right, so that is the alternating current, and this is the graphical representation of an alternating current. Okay, so an alternating current looks like that. Okay, so AC generators has different variants. So it is as big as this or as portable as this. Okay, so this is a household generator. Now, if there's a sudden blackout, on your area, you can use this one as your source of electricity. All right, you can connect devices here. Okay, that can this generator powered that can power up the devices that you will connect on this generator. Now, meanwhile, this one are large generators that are found in power plants. All right, so they are either connected in a hydroelectric power plant, or sometimes they are connected in a wind turbine. All right, so these are AC generators that are found on those power plants. All right, so now the idea of electrical generators are electrical energy is created from it, but the electrical energy from the generator is not created from nothing. So, electrical generator still follows. It doesn't produce, or the energy that comes from your generator doesn't come from a free energy source. There's no such thing as free energy. Alright? So, it follows the law of conservation of energy, that energy cannot be created nor destroyed. It only transforms from one form to another. So, in this case, mechanical energy was transformed into electrical energy. Now, the question is, where does that mechanical energy come from? All right, so it may be coming from a falling water, from a wind, from a steam. All right, so and many ways of producing this mechanical energy. So, but the thing here is the energy is not created nor destroyed. Okay, in the process. Okay. And the energy must be continually to be supplied to keep the disk in your generator, or the rotor, to keep the rotor inside your generator spinning. If it stops, the electricity production stops. Alright? So, example here, we have the hydroelectric power plants. Alright, that contains hydroelectric generator which is connected to a turbine, and the turbine is spin. Alright, the turbine spins using falling water. Alright, using falling water, and as this falling water continues to spin this turbine, the electricity is continually produced in the process. Example here, we have the Hoover Dam in United States. Alright, so in the Philippines, we have here the La Mesa Dam. Alright, so we have here the Magat Dam. Alright, so we have here the Angat Dam. So those dams that we have right there, we have here in the Philippines, has this generator that generates electricity, that supplies electricity throughout the country. All right, so in Luzon area. All right, in Mindanao area, there is another hydroelectric power plant there, the Maria Cristina Falls. All right, so there you go. Okay, so that is the application of generator, all right, in production of electricity. Okay, so that is the generator. So the generator uses electromagnetic induction in production of electricity. That's the sole purpose of your generator, to produce electricity. Now, what about its counterpart? All right, what about its counterpart, which is the transformer? All right, so the transformer. Transformer is similar to your electric generator because it uses electromagnetic induction. Alright? It uses electromagnetic induction, but it doesn't create electricity. Alright? The difference between transformer and generator is the generator creates or produces electricity, while transformer doesn't produce electricity. But it converts electricity, alright, into something more useful. Right? So in this particular diagram that we have right here, so in this particular diagram that we have, so we have here on your transformer, there are two things that you need to take note of. There is an input and there's an output. All right? Now the transformer safely converts this voltage. The transformer converts this voltage into a more useful and safely amount. All right, in a more safe amount and a more useful amount. All right, so in the input part of your transformer, the voltage is higher, and the current is, by the way, this is a voltage, this is the voltage, and this is the current. And the one below is the power. So volts is the unit for voltage. Ampere, capital A, is the unit for current. By the way, this is capital V for voltage or volts, and capital W for watts, for power. All right, so that's the SI unit for power, watts. All right, so as you can see here in the input part of your transformer, the voltage is higher compared to the secondary. All right, so the purpose of this one is for the transmission. All right, the purpose of this one is for transmission, because at higher voltage and lower current, it is safely to transmit electricity from the source down to the household. Alright? So with this particular amount of voltage, it is safely to transmit power from the source, whatever it is, hydroelectric, wind power, or something like that, to the household or residential. All right. So why is it that there is only there is a very um, less current on the input? It's because of one thing. It's to avoid too much resistance on wire, right? In the transmission wire. Now, imagine if you have a high current and a high voltage at the same time. What will happen to these wires that you have over here? It will melt down. Alright, so this wire will melt down and will not be able to transmit electricity. Or if it has, if it will not melt down, the okay, there will be a lot of heat loss. Alright, there will be a lot of heat loss that we should be able to convert into electricity in the first place, but since it is converted into heat, it will be a loss of power, all right, in that process. So that's the reason why, because of transformer, you can transmit any amount of electricity at higher voltage but lower in current. All right. So, but the power, as you can see here, in the secondary output, the voltage is less and the current is high. Now, what's the use of this one? This is for household use. All right? You cannot use a voltage as high as this in your electrical appliances at home, or else these appliances will blow. All right? So these appliances will blow. So what the transformer does is to convert that voltage into a much useful and safe voltage for your appliances with the higher current on it. But as you can see, the power doesn't change. Alright, so as you can see, the power doesn't change in the process. So that's the purpose of your transformer. Alright, to convert those voltage for transmission lines to a more useful ones that we have right here. So who do you think is the one who invented this transformer? Alright, so imagine how bright this person is. Alright, he invented this transformer out of nothing. Okay, so who do you think it is? Okay, so that is the transformer. So again, it uses electromagnetic induction. So if you are familiar with transformers that are found in an electrical post on your area, all right, so it looks like this. All right, there are small transformers, there are large transformer as large as this, or even as large as the one found in a substation, a power substation. All right, so as large as that. All right, so just a trivia, this transformer that you have right here has a coolant inside in a form of an oil, a mineral oil. All right, so that mineral oil is a form of coolant that cools the transformer inside this one. So as you can see here, you have your input wire. Over here, you have your input wire. So this is your input wire. And this is your output wire. So these wires that you have right here will go to your power outlet at home. Alright, so this secondary wires that you have right here goes to the power outlet at your home in a much safer voltage to use for your appliances. Alright, so you can find transformers in your chargers, cell phone chargers, or even microwaves. There's also a transformer in your laptop chargers, something like that. Power supplies on your desktop PCs. All right. So generally speaking, there are a lot of ways that we can use a transformer. All right. So one particular way that we can use it is to transform this voltage into a much useful voltage that we have at home. Okay. All right. So what is let's have the idea about the transformer. The transformer has two coils, one primary and one secondary. The current in the primary coil creates the magnetic field. So as we all know that as what Hans Christian Ørsted said, that moving charges creates magnetic field. So it follows the same principle, all right? But in the primary coil, you produce your magnetic field. As the current inside your primary coil flows, it produces its magnetic field. But the secondary coil is the one that uses the electromagnetic induction. Alright? So it will capture this magnetic field. It will capture this changing magnetic field that you have right here on the primary coil, then create the current for the secondary coil. Alright. So, a transformer only uses alternating current. There's no such thing as DC transformer. Alright, so there's no such thing as DC transformer. So, let's go to the simulation to, I will show you that one in the simulation that we have right here. Alright, so here we go. Okay, so this is an electric generator. So, as you can see, in an electric generator, there are moving parts. Alright, so you might wonder, why is a transformer an electromagnetic induction device? Alright, in a generator, there's a moving part. So we call this moving part rotor. So as this rotor continues to move, it will continue to produce electricity. Alright, it will continue to induce electricity on this current carrying wire over here. As long that this one moves. Alright, as long that the rotor moves. But in a transformer, there's nothing moving. Alright, there are no parts that is moving. Alright, that is one of the transformer is one of the genius, alright, one of the ingenious innovation coming from an inventor that we have a while ago. Alright, so who is that particular inventor? Now, as you can see, battery runs, okay, the battery is the power source that produces direct current. Right? So as you can see, the direct current is in one unidirectional flow. Alright, so there is a magnetic field around this current carrying wire. Alright, so as what Hans Christian Ørsted said. But, do you think it is changing? Do you think this is a changing magnetic field? Alright, so it is not a changing magnetic field because neither the direction or the amount of magnetic field is increasing inside this coil. Alright, neither both of them. So, the only way that you will increase the magnetic field inside this coil is by moving the coil itself, which is totally ridiculous. Alright, that will not become a transformer. Alright, that will not become a transformer if there is something that is moving. Alright, so that is why the inventor of this transformer uses another invention, which is called the alternating current, in order to safely convert this electricity to a much useful voltage. It's either for transmission or for household use. Alright, so as you can see here, this is an alternating current. So, as I've discussed earlier, that alternating current has two directions. Periodically, it changes direction over time. So, if you increase the frequency of this alternating current, alright, the changes in your magnetic field also happens in a much faster rate. Now, also, if you increase also the amplitude of that particular alternating current, it will also change how this alternating current is being delivered. Alright? So, in this case, you have now a changing magnetic field. So, that's the idea, right? In your electromagnetic induction, the key idea here is that changing magnetic field creates electric current. So, this is now your changing magnetic field because the magnetic field changes direction. Alright? It changes direction even though we are not moving the coil over here. Alright? Even though we are not moving the coil over here, still the magnetic field changes in direction. So the thing here is there's no moving parts, only the alternating current or the current inside this coil of this coil of wire only moves. So it changes the magnetic field, it induces the current on the secondary coil, it produces an electricity. Alright, so it creates this electricity. Alright, so it creates this electricity in the process. So that's why the light bulb lights over here. Right? So that is the basic idea about the transformer. Alright? So very ingenious, right? So again, the changing magnetic field is because of the alternating current flowing inside the coil of wire. As we all know, alternating current is a two-direction current. It changes direction periodically. So as it changes direction, it changes also the direction of your magnetic field, inducing a current on your secondary coil producing or creating this electricity that is useful in some or in many ways. All right, so that is how a transformer works. Again, transformer works only in alternating current. All right, so let's go back to our main slide. Okay, so take note that one. All right, so next. So the third one is, as the current changes, so does the strength and direction of the magnetic field through the coil. Alright, so does the magnetic field through the secondary coil. Next, the changing magnetic field through the secondary coil induces the current in the secondary coil. The secondary coil connects to your home wiring most of the time. Alright, so most of the time. Okay, so this is how the transformer looks like. Okay, so if we will increase this one, this is the primary coil, and it has its primary voltage flowing on it. So this primary coil produces this magnetic field. Alright, so with the use of the iron core to stabilize this magnetic field, the secondary coil will capture that magnetic field coming from the primary coil. Now, as it changes, since it is an alternating current, as it changes, it creates or it induces current on the secondary coil. Thus, thus producing creating an electrical current that will be useful to some many electrical appliances. All right, so this is a typical build of your transformer. It has a primary coil, it has a voltage, and secondary coil, and we have your iron core. Right, so okay, so what is the relationship between the voltage and number of turns? The relationship between them is, all right, so the relationship between them is the result of the two coils having different number of turns. All right, so what I want you to take note of is there is no such transformer that has a primary and secondary coil that has the same number of turns. Take note that one, huh? All right, so take note that one, that there is no transformer that has secondary and primary coil that has the same number of turns. They always have different number of turns. It's either vice versa, or the one that you have right here, the primary coil has more turns than the secondary coil, or the other way around. Okay? So they must have an opposite number of turns. Alright? So that is the transformer. So it looks like this. The primary coil, again, creates this magnetic field. So it creates this changing magnetic field, and it will be captured by the secondary coil on the other side, and it will create this induced current using the changing magnetic field, and creates this current that goes to your appliances. All right, so don't forget the iron core. The iron core at the middle is the one that stabilizes this magnetic field, all right, so that the magnetic field will not go somewhere else. All right, so there are two types of transformer. So we have here the step-up transformer and the step-down transformer. So what it does is, from the word itself, step-up, it elevates the voltage. The step-down, it decreases the voltage. All right, for useful purposes. All right, let's start first with the step-up transformer. Now, what you should take note of with the step-up transformer is that the primary coil is less than the secondary coil. And the voltage is from higher, or from lower voltage, it will convert that voltage to a higher form of voltage. Right? So that is the step-up transformer. All right. So another one, we have the step-down. The step-down transformer, okay, the step-down transformer has a primary coil which has higher number of turns than the secondary coil. Okay, so what it does is the step-down transformer transform higher voltage to a more lesser voltage. Alright, so that is the step-down transformer. Okay, now in terms of the current flowing here, the current flowing on this transformer has a higher amount. Alright, so the current here has higher value, and when it goes to the secondary coil, the current now is in lower value. Alright? So it decreases the current. Now, in the step-down transformer, the current on the other side, mainly the primary coil, is in lower value. Then when it goes to the secondary coil, the current on the other side now has a higher value. Alright? So, higher value. So, what we have right here. So, this is the current. Now, but the power, alright, but the power on both transformer are equal. From the primary coil, input and output power should be equal. As what we stated a while ago. Alright? So, okay. Only the current and the voltage will vary, but the power stays the same. Alright, in an ideal transformer. Alright, so this is the transformer equation that we have right here. Now, if you want to compute, so if you want to find out the secondary voltage or the primary voltage or the number of turns in your primary coil or secondary coil, you can use this formula. So, instead of using 1, I will replace it with primary. Alright, so the second or the 2 is replaced by secondary. And we have the primary over here and the secondary. Right? Now, the idea is the same changing magnetic field in a coil with 100 turns produces 10 times voltage of the induced current as the coil with 10 turns. So, how does it work? Alright, so how does it work? Suppose, alright, so how does this formula work? Suppose, on the primary voltage, okay, so your primary voltage has 1 volt. Alright, so 1 volt only flowing on that. Now, what is the secondary voltage if you have on the primary coil, you have 100, or sorry, you have 10, alright? You have 10 turns, and on the secondary coil, you have 100 turns. What will be the voltage? Alright, so as you can see here, alright, so as you can see here, so the secondary voltage will now be also 10. Alright? So, if you use our calculator, so 100 over 10, that will be 10. So, 10 volts. So, meaning to say, in the secondary coil, you can produce a 10 volt current. You can produce a 10 volt current with just, okay, with just a 10 turns on your primary coil. Alright? With just the 10 turns on your primary coil. As long as the secondary coil has more turn than your primary coil. Alright, so that's the idea. They should never come in the same number of turns. Alright, so they should not come in the same number of turns. They should be opposite to each other. Alright, so that is the first transformer equation that we have right here. So please do take note that one. And also, the second transformer equation is this one. Now, if you want to compute power, the formula for power is voltage times current. Alright, so voltage times current, power is in watts, voltage is in volts, capital V, and current is in ampere. So voltage times ampere or current in amps is equal to watts. Alright, so now more so, okay, so the voltage in the primary is equal to the voltage in secondary. So this is the second formula for our transformers equation. Alright, now this formula is used if you want to find out what is the current flowing in those two coils respectively. Now, if you want to find out the current in the primary coil, you can use this formula. You just rearrange it. Now, if you want to find out the current flowing in the secondary coil, you will rearrange this formula to make it useful in finding the secondary current in your secondary coil. Alright? So, but the idea is the power output and the power input must be equal on each and both coils. Alright? So, that is the second transformer equation that you will have. Alright, so let's put that let's put the equations to good use. So you can pause this video if you want to answer this problem. Alright, beforehand. Okay, so what do we have right here? A cell phone AC adapter reduces the 120 volts AC to 6 volt DC needed by the phone's battery if the primary coil has 240 turns And the question was, how many turns does the secondary coil have? Alright, so first is the problem is looking for number of turns in the secondary coil. It was stated very clearly on this problem. Now, our problem is who is the primary voltage and who is the secondary voltage. Now, in this case, the primary voltage was mentioned first before the secondary voltage. So we can assume or we can conclude that this is the primary voltage and this one is the secondary voltage. All right? So based on the sequence it was mentioned in your problem. Alright, so that was it. So the primary voltage was 120 volts and the secondary voltage was 6 volts. Alright. So the primary coil has 240 volts. So volts or 240 turns rather. How many turns? Alright, so we can use this formula, alright, to compute for that one. So we can rearrange the equation to look like this. And the answer should be 12 turns. Alright, so the secondary coil must have 12 turns. That's the complete answer on this particular problem that you have right here. Alright, so by the way, before we go to more sample problems that we have, okay, so let me show this one first to you. Okay, now in your cell phone chargers, there are things that are written there. Okay, like the one that you have right here. Okay, so I hope my camera will focus this one. Alright, so if it didn't focus properly. Now, on your cell phone charger, there is a transformer on it. Alright, so if it doesn't have a transformer, that is not a cell phone charger. Alright, a cell phone charger must have a transformer inside for it to safely convert that voltage that is flowing on your power outlet to a more useful voltage for your cell phone use. Alright? So, if your device has a transformer on it, it has a label like the one that you have right here that states the input voltage and the output voltage. If there is something like that, then therefore that device has a transformer. So as you can see in this device, it has an input voltage of 240 volts. Alright? At around 200, yan, 0.2 milliampere. Alright? At 0.2 milliampere or 0.2 amperes. Something like that. Alright? At 0.2 amperes. Yan. So that's the input voltage and current. So as you can see, it has a higher voltage on the input because that is the one that is flowing on your power outlet. Now, the current is much less, all right? The current is less, okay? Because in the power outlet, the current there is somehow being decreased, all right? Now, it will increase on the power output of this device that will flow here to your cell phone. Alright, so the power output of this device is 5 volts. Alright, so as you can see from 240, it is lessened to 5 volts for safety purposes. Now, what happens to the current? The current now is increased from 0.2 amperes. Okay, from 0.2 amperes, it is now changed to 1.5 amperes. It is now changed to 1.5 amperes. So, that's a dramatic increase. So, for what purpose? Now, your cell phone will not work if the current is less. Alright? The cell phone charger or the cell phone battery will not charge if your current is less. It will take time to charge. It will take forever to charge if the current is less. So, the transformer transformed that current to a higher form in order for your cell phone battery to charge faster. Alright? So, that's the importance of your transformer. You can see this label in your laptop chargers, power supplies, and any device that uses transformer. Alright? Alright, so let's go now to the first sample problem. Okay, so the first sample problem was a transformer has 500 turns of primary winding and 10 turns of secondary winding. Again, you can pause this video if you want to answer the question. Determine the secondary voltage if the secondary circuit is open and the primary voltage is 120 volts. Alright, so let's list down all the given facts about this problem. Alright, so in the primary winding, so this is a clue. So that the primary, this is, the 500 turns is the primary coil turns. Alright, so what is the secondary turn? Secondary coil rather. Alright, so 10 turns. Okay, so secondary coil is 10 turns. Alright. Then, what is the secondary voltage? That is the one that we are looking for. And the primary voltage is... Alright, so the primary voltage was... primary voltage was 120 volts. Alright. 120 volts. So, what do we have right here? So, we will use the formula. Alright, so Vp over Vs is equal to Np over Ns. Alright, so we will just rearrange this one. Alright, so we will just rearrange this one. So, Vs is equal to Vp times Ns over Np. Alright, so let's substitute all the given values that we have right here. So the primary is 120 volts. I will include the unit. So since this is not a unit, so you can have it dimensionless or unitless rather. All right, so the secondary is 10 turns over 500 turns. All right, so what will be the secondary voltage? So the secondary voltage is... Okay, so that is 2.4 volts. All right, so what happens here? Okay, so from higher voltage to lower voltage, so that is a step down. This is a step down transformer. So step down transformer here. All right, so 2.4 volts. So what is the complete answer? So the complete answer is the secondary voltage. The secondary voltage is 2.4 volts. So that is the complete answer for this problem. Alright, so that's the problem number 1. Next, let's go problem number 2. Alright, so in this problem, we are asked to find only the ratio. Alright, what is the ratio of the primary turns to the secondary turns for a transformer that has an input of 20,000 volts and the output of 400,000 volts. So that's alright, so what kind of transformer is this one? Okay, so from an input of 20,000, it will be converted to an output of 400,000. This is a step-up transformer. So you can probably find this transformer in power plants. Alright, so near the power plants. So, what do we have right here? The ratio of number of turns. So, what is the ratio of turns between NP over NS? So, this is the ratio that we are looking for. Alright, so what do we have right here? The voltage. So, the primary voltage is 20,000. Input, that makes it the primary, 20,000 volts. And the secondary voltage is 400,000 volts. Alright, so using the formula, Vp over Vs is equal to Np over Ns. Alright, so since this one is the one that we are looking for, we can have this one only. So we have 20,000, right? So 20,000 volts over 400,000 volts. Alright, so we have 400,000 volts. Alright, so what will be the ratio that we have? Alright, so dividing it properly, so we have, the ratio is, okay, NP is equal to 1, and your NS is equal to 20. So the ratio for this one is the ratio of primary turns. Alright, so the ratio of primary turns to the secondary turns is 1:20 respectively. So that is the complete answer. Again, the ratio of the primary turns to the secondary turns of this transformer is 1:20. Alright, 1 is to 20. So this is the correct answer for this problem. That was problem number 2. Next, problem number 3. Right, so problem number 3. So a transformer has a primary voltage of 480 volts and a secondary voltage of 120 volts. If the primary windings have 700 turns, how many turns are in the secondary winding? So this time we are looking for number of turns in the secondary coil. Alright, so you can pause again this video if you want to answer it beforehand. Okay, so let's start with the primary voltage. So the primary voltage was 480 volts. Then the secondary voltage was 120 volts. Sorry, 120 volts. Then on the primary winding, so we have 700 turns. And we are looking for the secondary winding. Alright, so we are looking for the secondary winding. So again, we use, okay, what kind of transformer is this? Alright, so this transformer is a step-down transformer. Why step-down? Because primary voltage was decreased to 120 volts. Alright, this is a step-down transformer. Alright, so let's put it right here. So VP over VS is equal to NP over NS. Alright, so okay, so the formula that we will going to use in this computation is, okay, so since NS is the one that is missing, alright, so we have VS times NP over, alright, over BP. So that's the formula that you're going to use to find the secondary number of turns. Alright, so 120 volts times 700 over, alright, so over, what is the other one? So 480 volts. Alright, so the voltage is being cancelled. So what do we have right here? What is the NS? Or rather, okay. Alright, so what is the NS? Okay, so what is the secondary voltage? Yeah. Alright, so what is the secondary voltage? Okay, so 120 times 700 divided by 480. So the secondary voltage, or the secondary turn is 175 turns. Now, in a complete statement, the transformer must have, alright, so the transformer must have 175 turns of secondary coil. Alright, so that's the complete answer. Alright, so 175 turns. That's the third problem. So the fourth problem that we have right here, the fourth and last problem that we have, a transformer operates on 2,500 volt line and delivers a current of 80 amperes. If its turn ratio is 20:1, alright, primary 20, secondary is 1, determine the secondary voltage respectively. And the next question is determine the primary current. Also determine the power output. Assume this is an ideal transformer that works in 100% efficiency. Alright, so you can turn off this, you can pause this video. You can pause this video if you want to answer this beforehand. Okay, so what is our value here? What are the given facts? Alright, so let's write down the primary number of turns, secondary number of turns, primary voltage, secondary voltage, primary current, secondary current, power output, and power input. Alright, so what is the primary number of turns? Alright, the primary number of turn is 20, secondary is just 1. Alright, Next one, primary voltage and secondary voltage. So since the problem is obviously asking you to find the secondary voltage, so this one makes the primary voltage. So this one will be the primary voltage. So that is 2,500 volts, and the secondary voltage is missing. Right. Next one. For the primary current, alright, so for the primary current, so delivers. So there is a word here, delivers. So it means that this is a secondary current. Alright, this is a secondary current. There is a word deliver. So this is on the other side. Alright, so this is the secondary current, that is 80 amperes. So we are asked to find the primary current. So that is also missing. Now, what is the power output and what is the power input? Okay, so the first thing to do here is use this formula. Alright, so use this formula. Okay, so after getting the secondary voltage, use this particular formula. Right. So we have primary current, secondary voltage times secondary current. Now, after this one, alright, so after this one, okay, you are now ready to find the power input is equal to power output. Alright, so let's start. Let's start first with finding the secondary voltage. So in this case, what we will going to use here is we will find the secondary voltage. So Vs is equal to Vp times Ns over Np. Right. So let's put those values here. So 2,500 times 1. Alright. Over volts. Over which is 20. Alright. So what will be the Vs? The Vs should be, okay, so 2,500 over 20, that is 125 volts. Alright, so 125 volts. The complete answer is the secondary voltage of this transformer is 125 volts. Alright, so we have now your answer here. Now, since we have your 125, we can now use this formula. Okay, we can now use the current for voltage and current formula over here. So we have so we have 2,000. We are looking for the primary current. Okay, so we are looking for the primary current. So IP is equal to voltage secondary, current secondary over voltage primary. Alright, so we have, what is the secondary voltage? So we have 125 volts times, which is the current of 80 amperes. Right. Over the primary voltage of 2,500 volts. The voltage is cancelled, so leaving the amperes behind. So the primary current is, okay, the primary current is 125 times 80. Right, so 125 times 80, 10,000 divided by 2,500, that is 4 amperes. Alright, so the current on the primary side is 4 amperes. Alright, so the current in the primary side is 4 amperes. So we have now the complete set to compute for the power input and power output. So, okay, now we are now the value of your primary voltage is 2,500 multiplied by 4 amperes. The secondary voltage has 125 volts and the current that it contains is 80 amperes. Right. So, you just multiply these two respectively, then the power output or the power of your transformer, alright, so if you are looking for the power output, so whatever power output comes out of this, whatever output comes out as an answer is the same answer as in the power input. So it will become 125 times 80, that is 10,000 watts. Alright, so that is the same also as the power input. So the power input also is 10,000 watts. Right? So it's the same power input. So basically speaking, that is the fourth and final problem that we have right here using the transformer equation. Now, what kind of transformer is this? All right, so what kind of transformer? So if the primary, all right, if the primary has more number of turns than the secondary, all right, this is a, all right, so this is a step down transformer. All right, so this is a step down transformer used in this problem. All right, so step down transformer. All right, so that's the fourth and final problem related to transformers equation that we have. Okay, and now we end up our before we end up our video lesson for this session. So okay, the man behind the electric generator, the AC generator, the alternating current, and the transformer we discussed today is none other than Nikola Tesla. Okay, Nikola Tesla is a Serbian-born engineer. Alright, he is a Serbian-born engineer, and one trivia about Tesla is that he was born during a lightning storm. Alright, during a thunderstorm. Alright, and his her mother, alright, her mother said that this child, alright, that Nikola Tesla will be a child of light. Alright, and it does. Alright, and it does. So because of Nikola Tesla's innovation or invention, we have now the alternating current that we use in our home, the device that uses transformers, the cell phones that we have, the wireless chargers that we have, the Bluetooth, the radio, all right, the Bluetooth earphones that you have, that you are using right now, the electric cars that we have right now. It's because of this man over here. He is an underrated physicist and an engineer na that is not well known to some people. All right, he is not well known to some people. He is an underrated person. All right, so this is his patent of the AC generator, and also we have the patent of his electric transformer. Right. So he is the proponent also of the Tesla coil. Alright, the Tesla coil, and many more, alright, devices, alright, including the remote control, the drones, alright, the remote control drones that you have, if you are familiar with that one, that technology today. The remote control drones is, was conceived by this person during his time, okay, that was Nikola Tesla, okay. So throughout his career, because of his scientific wisdom and creativity, the others thought the technology was impossible. He made it possible. All right. So the moral lesson of this topic that we have right here is more about of a compassion, because Nikola Tesla lived a life of full of compassion. All right. He lived a life of full of compassion, and he died broke. Yeah, he died broke, and he has a mental breakdown at the end of his journey, right? So maybe you can live like him, all right? Maybe you can live like him, but not too much, all right? So that's the take of this topic that we have, right? The topic that we have today, it's because of Nikola Tesla, and so I hope you appreciate his effort of bringing this invention to us in this in creating this modern world that we have right now. All right, that ends up our topic for this video lesson about electric generator and transformer. So I hope you did learn something from this video. If so, you hit the like button. on this video. And also, don't forget to subscribe to my channel. It will help me a lot, and hit the notification bell so that you will be updated with more videos like this in the future. All right, so don't forget, if you have something or if you have a question about this video, if you have suggestion about this video, you can write it down in the comment section below. All right, so that ends up our video lesson for this session. So let's see each other next time, guys. Peace out.
子供なのね、夢を追って傷ついて嘘が